I'll be explaining sensing trending topics in Twitter using the document pivot and frequent pattern mining methods. Document pivot topic detection method uses locality sensitive hashing LSH to rapidly retrieve the nearest neighbor of a document and accelerate the clustering task. The principle behind this method is the same used for near duplicate detection in similarity based aggregation steps of pre-processing phase. Performing online clustering of posts. This requires computing the cosine similarity that is the TF-IDF representation of an incoming post to all other posts processed so far. If the similarity to the best matching post is above some threshold theta TF-IDF, then assign this item to the same cluster as its best match. Otherwise, create a new cluster with a new post as its only item. The best matching tweet is efficiently retrieved by this method. Next is filtering out the clusters with item count smaller than theta TF for each such cluster. C. Compute score as follows: score C equals summation over all documents and summation over all words e power minus the probability of word I in document J. Using such scores and similarity measures, the clustering results are as follows. We are doing it on a current tweet size of 30,000 tweets, on which 1887 clusters are formed, out of which the top cluster groupings has some sample words such as football, Klopp, Liverpool, manager, club, jargon, Klopp, LFC and official. This was the result using document pivot method. Now we move over to frequent pattern mining method. In this method, we are using three subphases. Frequent pattern detection. The frequent pattern growth algorithm is often used as a comparative baseline for frequent pattern item set mining due to its good performance. Our implementation uses distributed version of the algorithm called parallel frequent pattern growth that is optimized for use in Hadoop cluster. FP detection requires 3 rounds of map reduced processing. Firstly, keywords list for each time slot. The initial step of the FP growth algorithm is to create a list of keywords sorted by frequency. A minimum support is used to reduce the number of keywords being investigated. Parallel construction of an FP tree data structure is done for such as each time slot. An FP tree sorts the pattern according to the co-occurrences and their support. Frequent pattern extraction. For each time slot, the parallel FP tree structure are aggregated and analyzed to produce association rules on the transaction set in the form of word 1, word 2 with probability W with probability I gives word 3, word 4 with support PI. Now FP ranking, which is used for ranking the frequent identities generated only. These are done on those transactions which have minimum support of 0.001 by partitioning and running on distributed clusters of partition size 10. Furthermore, the results we get are sorted as per maximum m length of item sets, and we are taking 2 item sets in the descending order which don't have any elements in common. Now the approach used was running frequent pattern mining algorithm on Spark clusters, feeding with tweets sorted time wise and constructing the item set tree with minimum support pruning till 0.001. Furthermore, the task was accomplished on distributed cluster of 10 tasks, and finally results were sorted and combined.